Okay? They were very significant differences, right? So one of the teams had all the testing fully integrated into the sprints. Another team, some of the testing was integrated into the sprint, but most of the testing was actually happening one sprint behind, so-called N+1 model, where there's a lot of development being done in sprint N. The testing of the content of sprint N is done in sprint N+1. Okay? Now there are people, agile purists, who would say, that's not agile, you can't do that. Hey, guess what? People are, right? The reality is that people create concepts, and those get thrown out into the broader world, and the broader world does with them what they want and what works for them, okay? So I think, can't remember where exactly I read this. One of the analyst groups, it might have been Forrester or Gartner, I don't remember which one, but they said that one of the key signs that Agile had made the transition from the fringe to the mainstream was the abandonment of dogma. Okay? That it was no longer a handful of people sitting around saying, that's Agile, that's not Agile, and making the determination. Now the idea is out in the mainstream, and they're being adopted and used however works for the organization, right? So be ready for that. Don't be a dogmatist, right? Don't go and say, oh, well, you know, I read the Agile Manifesto and you're not doing it right. You know, if it's working, guess what? You're doing it right, right? If it's working for your organization, you're doing it right. Now, yes, please. Not very well. If you could yell a little louder, I'll repeat the question.
It was more developer friendly, but it was not QA friendly. In the sense that
QA friendly?
Sorry?
It was developer friendly, but not QA friendly.
So, why I say that is because we were going through 2-week sprints. So the way I say, the reason I said it was developer friendly was because we were going through 2-week sprints, where the N+1 model, and what ended up happening is when we got a build 1 week on, the developer schedules were all good, but the QA schedules got delayed because of the obvious bugs and stuff like that. So this kept on moving, and we were at the point where QA was deemed to be inefficient through it.
Right.
And the other thing that I found in Agile way of doing it is there was no room for us, or there was no bandwidth for us to increase efficiency. We were doing the same things sprint after sprint. QA could not increase efficiency through, let's say, automation or anything else.
Yeah.
Maybe we did not do, what ended up happening is we dropped the Agile model at some point of time. But do you have any suggestions of how to get this better?
Yeah, I think it's an excellent point. That's actually this bullet right here is, Agile is in the mainstream, but it's not, we haven't gotten testing best practices integrated into it yet. And your story is by no means atypical. I have talked with a number of clients around the world, and that testing getting squeezed at the end, inadequate support for automation of the tests. That's the situation where Agile means the developers do what they want to do, and it's not about the broader definition of success, right? And that's certainly not consistent with what Agile should be, and it's not. It doesn't work, as your organization found out, that ultimately if it's still, you know, testing gets squeezed at the end of each iteration, then you've just taken the classic problems of the sequential lifecycle model and sliced it into little bits, and you've got little chunks of pain spread over a long period of time as opposed to a big chunk of pain at the end, right? So where's the advantage of that? Yeah, so that's something that we as test professionals can offer, how to integrate testing best practices into Agile methodologies, how to make that work. And it's automation, it's a focus on the early detection and removal of defects in the user stories / requirements, whatever you want to call them, in the code, in the design, right? All of those best practices that we've been talking about for years in the testing profession, they're different, but they're the same, if you know what I mean, right? Removing bugs early in the life cycle is always a good idea, whether you're talking about sequential or you're talking about Agile, right? So, yeah, this is a point, a major point. Think about how to integrate.
Can you hear me? Yeah. So the next big thing in the cloud front is, let's say 2015 is the SDN, the software-defined networking that's going to come up. The Ciscos and Junipers are getting ready to take networking elements to the cloud. What do you think would be the impact on general quality assurance and testing when more and more hardware and more of even the networking infrastructure is going to the cloud? I know there will be the impact on revenues of all these companies, but then what will be the impact to QA?
On testing, right. No, I think it's just more of what I was talking about in the previous slide, that you have more and more, reconfiguration of production environments that can happen on the fly. You've got more and more diversity in terms of the way that the production environments are implemented. I mean, I think it's just, it complicates planning for test environments. But at the same time, it creates a flexibility in terms of what's available to us in test environments. So it's like all of these trends, you can either be run over by them or you can ride them, So try to think about how you take advantage of them too. Okay, so one last point on Agile that I want to throw this out here as a challenge. I like a lot of what I see in Agile, but one of the things that disturbs me is that more and more I hear about people not capturing any information about defects found, at least those defects that are found and removed within a single iteration. The argument made for this is that, well, we're lean, don't document defects, stop the line, fix the problem. Oh yeah, okay, I understand the efficiency argument. Efficiency argument works if you assume that there's only one way of capturing information about defects, and that involves filling in a complicated defect report in Quality Center or some similar tool, okay? But that's not the only option for capturing the relevant information about defects. And if we do not study our mistakes as software engineering professionals, we cannot get better. If you do not keep track of and watch for patterns in the kinds of mistakes that are being made, the sources of those mistakes cannot be removed. Okay? That's the risk of this approach in Agile to saying we don't need to have metrics, we don't need to have measurements, we don't need to track defects. So I would say be very careful about that. You're likely to be either having already run into that or you're going to run into that. I think that's a very dangerous idea and something that we should try to motivate people to avoid. And the way to motivate them to avoid that is sell them on the benefits of what kind of information and what kind of learning and process improvement can be done based on really good defect tracking information. Okay? If you know where defects are being introduced and the kinds of mistakes that are introducing defects, you can improve the process. If you do not know that, you cannot make the improvements. Okay, so the explosion of test configurations. Here comes another trend. Again, challenges and opportunities. I was in Moscow a couple years ago, and one of the, speaking at a conference, and one of the attendees made this memorable comment. His organization produced mobile applications, and he referred to the cubic meter of devices. You imagine a box 1 meter by 1 meter by 1 meter, absolutely full of tablets and handsets and other devices. And then you think about, well, what's all the different operating systems, browsers, security software, versions of Java and so forth that could be running on those, and it's combinatorial explosion from hell, right? I mean, we've always dealt with the combinatorial explosion in testing, but here it is again, bigger and better than ever. Yeah? So, how do we deal with that? Well, I think it's very important that we deal with that with our brain, okay, not with brute force. Brute force is not going to be a good approach to dealing with this situation. So, for example, some people just say, oh, break out the pairwise testing tools. Clearly, we have to do pairwise testing of all the possible pairs. Really? Why? Why is a good question, isn't it? Why is a good question to ask in a lot of circumstances, and this is one of them. There are people running around touting pairwise as how to deal with this. Why? Is it really that important that all of these pairwise combinations be tested? Do we actually have some reason to think that there's going to be interaction between certain combinations? I'm not saying don't, I'm saying question it. Pat, let's have an explanation for that before people start running around going, orthogonal arrays are going to save the world. Okay? Because I see over-application of this idea, of this technique, promoted as a solution to configuration combination testing, and I have not always heard a good answer to that question of why should we do that. Okay? So ask that question. Maybe we should be more focused on the configurations that pose the highest risk, either from a likelihood to fail or an impact of failure, right? Maybe we should be more focused on that. Maybe if we're going to do combinatorial testing, maybe we should focus it on the top 20 or 30 particular combinations that are most likely to cause us problems. And you also have to be careful, too, when you're doing combinatorial configuration testing, that you design the tests in order to expose combinatorial problems if they exist. One of the issues that I find with people that adopt pairwise just reflexively and say, well, we're going to do pairwise testing of the configurations and that's going to solve this problem. How do you know that the tests that you are running against those configurations are optimally designed to expose configuration problems if they exist? Okay, so think about this carefully. This is going to be a major challenge. If you can solve it smart, you can save your company a lot of money while at the same time mitigating the important risks. If you do it dumb, if you do it brute force, you're likely to spend a lot of money. You might make some tool vendors rich. Apologies to any tool vendors in the room that are selling pairwise combinatorial tools. But that's not necessarily the best thing that you can do for your employer or client. Okay? Also, we see an interesting rebound of the walled garden approach. Apple being the most famous for that, right? Nothing runs on the Apple ecosystem but that the ghost of Steve Jobs approves, right? I mean, they've created this bubble, right? Is that really where we want to see things go? Is that actually in the best interest of the users and the customers? I don't think so. I mean, you wouldn't want a situation where you could only put one brand of gasoline into your car. You had the Microsoft car and the Microsoft brand of gasoline, or the Apple car and the Apple brand of gasoline. I don't think we want that, right? What's in the best interest of the consumers of technology is commoditization. Commoditization is going to drive lower prices, and it's also going to drive increased competition and increased quality. So, something to think about. If you're, thinking you see yourself as an advocate for quality and an advocate for the customer or user, just keep that in mind. So I think this is an interesting trend, not necessarily something we can do a whole lot in the testing profession, but I think it's something we should consider. Now, maybe you can take advantage of the cubic meter of devices by working in a compatibility test lab that has them. Right? So there's a couple ways to approach the compatibility testing problem. One is to test it yourself, and the other is to outsource it. I think this is going to be a growing trend of organizations that have the hardware, the software, the know-how to say, hey, don't worry about the cubic meter. We've got the cubic meter. Outsource your compatibility testing to us, and we'll mitigate your risk. And if you can do that in a smart way, help clients do that in a smart way, there might be some significant money to be made here. Okay, so big data. Big data is a big phrase, right? And certainly there's a lot of big data repositories. There's a certain U.S. citizen floating around, God knows where, last spotted in an airport in Moscow. At least he's kind of a U.S. citizen. He doesn't have a valid passport anymore, but I'm pretty sure he's still considered a citizen. So he kind of opened the lid on a whole bunch of big data that was going on about phone calls and web access and what the National Security Administration in the United States was doing to try to find people they think are bad guys, right? So I think this gets people thinking about big data from a point of view, wow, there's a lot of this out there, right? And a lot of organizations are doing a lot of different things with it. So you can say, well, the governments have it, but it's not just governments, of course, right? Of course, most of the big data in the world is really floating around in places like Google and other organizations that are able to capture large amounts of clickstream information and use that to learn interesting things about potential customers, right? So, lots of data. How do we test this? Right? This is a challenge. I mean, large data repositories have always been an interesting challenge from a testing point of view, and this is just more so in the sense that now the big data tends to be less structured, right? I mean, with a SQL database, you could take a look at the schema, you could take a look at what the valid value ranges were for the different fields in the different tables, and you could generate data that was production-ish, right? And you could even potentially generate volumes of data that represented or were close to representing what was going to happen in production. With this kind of clickstream big data, forget about it, right? Testing with generated data, very unlikely that you're going to be able to replicate either in terms of volume or in terms of characteristics, unless you do some very, very careful study of the actual production data itself. You can't just look at the schemas, right? And of course, in a lot of cases, there's no schema to look at, right? There's no SQL involved with this. So, this is something else where it's a trend, and it's something that you as a test professional in the coming years need to really think about. How do I ride this? How do I take advantage of this? How do I get involved in testing systems that involve big data? Yeah. So size is an issue, the sheer volume of it. Anonymization. Can you actually use production data if it contains personal identifying information or other sensitive types of information? How do you deal with anonymization of huge volumes of data? Is that even possible? Right? We're talking about disparate but related data repositories in many cases. How do we anonymize them in a way that doesn't damage the testing nature of those data repositories? Huge challenge here. You have distributed pools of big data. Right? You think about Amazon, for example, which has a lot of different servers in a lot of different locations, and they're all selling out of more or less the same inventories, and those are not single repositories of data that they're pulling out of. How do they keep those in sync? The interesting testing problems there. Another interesting testing challenge, too, is that production data is inherently dirty.